Hello, students. Let's do some math. It'll make you better. Okay, let's do 1 through 15. Number 1, looks like we just have to take the derivative of the first times the derivative of the second plus the second times the derivative of the first. And looks like that is B. Okay. Number 5, nope, that would be number 2. Number 2, on which interval is the function increasing? They give you the function. So we're going to take the derivative, and that's 30 minus, or 300 minus 3x squared. Set it equal to 0. Looks like x is 10 or negative 10. On a number line, on an f prime number line, we put those two numbers down. When you graph this, you know it's a parabola that opens down, right? So it's negative to the left of negative 10, positive between those, and negative to the right. So the function is increasing when f prime is positive. So that's from negative 10 to 10. It's B. Okay, number 3. Simple. If you integrate secant tangent, the function that's derivative is secant x, tangent x is secant x, so this is A. And we need to take the derivative. F prime of x is 7 plus 1 over x. The derivative of 7x is 7, derivative of negative 3 is 0, and derivative of positive. Natural log of x is 1 over x. If it were a natural log of, x squared, it would be 2x over x squared, right? It's u prime over u, but anyway, that is it. And when we plug 1 in, looks like you get 8, so it's E. Okay, now number 5. Looks like we have to take some limits. There's the function, right? The limit as x approaches 2 is 2, and it exists. That's true. We're looking for what is false. Limit as x approaches the x value of 3 as the y value of 5. So it exists. Limit as x approaches 4 from the left is about 1.8, and from the right is 4. Those are not the same, so it does not exist. Limit as x approaches 5 exists, and the function's continuous at 3. Those are all true. So it is C. Okay, a particle moves along the x-axis. The velocity of the particle is this. So v of t is 6t minus t squared. And what's the total distance? So as long as it's positive over that interval from 0 to 3, we can just integrate it straight. So just let's look at it. We know that's a parabola that opens down. It goes through 0 and 6. Okay, I can find that, where it intersects the x-axis by factoring it and set it equal to 0, and that'll give you the zeros of it. I know it's a parabola. We know that about negative t squared. We know it's going to be a parabola that opens down. So from 0 to 3 is this area. So it looks like we can find the total distance by just integrating from 0 to 3. And add 1 to the power and divide by the new power. When you plug 0 in, you get 0. So all we have to do is plug 3 in, and that's 27 minus 27 divided by 3 is 9. So whatever number that is, looks like it's 3 9s minus 1 9. It's 2 9s. D. 6 is D. Okay. This is 3. This is y to the function to the 5th power. So anyway, its derivative is the derivative of the outside function, leaving the inside function alone, times the derivative of the inside function. Derivative of this is 3x squared. Derivative of negative cosine, there's a sign change, so positive sine of x. So we're looking for that. Well, not that one either. Looks like they took the next derivative. Oh yeah, there it is, e. Okay, almost halfway done. Okay. Number 8. Looks like they give you a table of values. Let's see if we're going to graph this. This is a rate, so yeah, we probably are graphing this. So let's graph this quickly. Here's 4, and when time is 4, it's 6.5, the rate in liters per hour. And then at 7, the width of that is 3, is 6.2. And then at 12, the width of that is 5, is 5.9. And then at 15, it's 5.6. Okay, so this says oil's being pumped at that rate per hour. Oh, at time equals 4, there's 50 liters. So we start with 50 liters. Okay, use the right Riemann sum. So we're going to use the y values on the right side of each subinterval to determine the height of each rectangle. Well, the width of that is 3. To approximate the number of liters. So the total number of liters is the amount you start with, 50, plus the integral of the rate, because you integrate the rate to get the total amount. So from 4 to t of r of t d, r of x dx. We don't want the variable in the interval to be the same as the variable in the function. So anyway, that function will give us the total amount. This one right here. So if we just plug in 15, we get 50 plus whatever this area is. So we should calculate this area. This is 3 times 6.2. This is 5 times 5.9. This is 3 times 5.6. Okay, so it's 50 plus 18.6. Oh, this is 5.6 minus 0.5. So 29.5. And this 3.3 times 5.6 are 3 15ths and 3 6/10ths. So 16.8. And that's pretty much 30. That's pretty much 18. So is that 48.1? 58, 9, 61, 64.9? Oh, plus 50. Can't forget that part. 1149, yeah, there it is, C. Okay, hopefully that makes sense. This one, we can see this function is undefined at 2, so we're going to have a removable discontinuity at x equals 2. So if we take this away, this discontinuity, we can plug 2 in and find the y value that will plug that hole. So when looks like it's 4 plus 1 is 5. So if this k value is 5, then it would be continuous. Then there would be a discontinuity at all. So E is the answer. Okay, number 10. The region in the first quadrant bounded by the line x equals 2 and e to the x over 2. Well, an exponential function grows exponentially like that. So we're looking for this region. This point, When x is 2, y is e, so it's the point 2e. So we're just going to integrate e to the x over 2 under this function from 0 to 2 dx. The integral of an exponential is the exponential, so this is really e to the x over 2 still. And this constant in front 1/2 generates a 1 over 1/2, which is a 2, so it generates a 2. So there is our answer. All we have to do is plug 2 in. When we plug 2 in, you get e to the 1. 2 times e to the 1 is 2e. And subtract what you get when you plug 0 in. When you plug 0 in, e to the 0 is 1. 2 times 1 is 2. So it's a 2e minus 2. Okay, everybody good, hopefully? Oh, here's another weird one. The absolute value keeps everything positive. Square roots do too, but the problem with square roots is you can't have negative numbers in it, and that absolute value will keep it positive. So if this were square root of x minus 2, it would just be the square root of x shifted over to the right 2. But then you couldn't plug any negative values in. But with the absolute value, you can. So it is defined for all x values less than 2, right? And x could be 2 because you can take the square root of 0. Okay, but this is the function. F is continuous but not differentiable at x equals 2. That's true. What are we looking for? Oh, we're looking for, it's probably A. But let's just keep going just to make sure. F is differentiable at 2? No, because there's a cusp. C, F is not continuous. That's not true. X can be 2. You can take the square root of 0. D, the limit as x approaches 2 is not 0. That's not true because it is 0. The y value of 0. And x equals 2 is a vertical asymptote. That's not true. It just stops right here at this point, 2, 0. So anyway, we've got false, 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 and false. So it is A. That was correct. The next one, we're just straight old integrating. They even give you the value for u. It's like a gift. But if u is x to the 1/2, du is 1/2 x to the negative 1/2 dx, which is 1 over 2 squared of x dx. And it looks like we have almost all that. We just need a 2 here. And a 2 in the denominator generates a 2 in the numerator. Okay, so now if we do this u substitution, we're going to replace the x to the 1/2, which is the power on e, with just u. And this 1 over 2 squared of x dx, 1 over 2 squared of x dx, all that turns into du. So the only thing that changes is it generates a 2. And our interval, we have to plug into this to find u values for the interval. So when you plug 1 in, you get 1 to the 1/2, which is 1. When you plug 4 in, you get 4 to the 1/2, which is 2. And do we go far enough? Yeah, it looks like it's C, right? Very good. Okay, so I've got a couple more to do. I have to stop at 15 because YouTube videos can't be longer than 15. So a particle moves along. Wait, I've done 15. No. I've done 12.